Okay, so we had just changed our window and we started to see our graph. Now remember, what we're trying to find is where the cost function, the marginal cost function, is equal to the average cost. So where they intersect, where these two functions intersect, would be where they'd be equal. So using the calculator and just graphing them, we can see here's one of ours and the other. So right here looks like the only place they intersect. And if they intersected on this side, on the negative side, we wouldn't want to use that. We wouldn't make negative items to produce. So it would be in this intersection here. So one of the fastest way to find that intersection is actually using the intersection button. You could also use the trace, but the intersection of the two functions would be more exact. So if I go to second and calc, so second trace, and you can see you have options for value 0, min, max, and we want to use intersect. So you can scroll down or just hit 5 and hit enter. The calculator will ask you questions for the first curve. It's usually on one of the curves, so we'll hit enter. And then the second curve, it'll be on a second function. We only have 2 in here, so it's fine. It's going to the right things we want. And then it says guess. You actually want to bring your cursor closer to where you think they're intersecting, as you can see on where they're about to intersect. And that will just give you the most accurate answer, the calculator. The calculator's telling us it intersects at 201.24. So that's our x value where we have the minimized, the average cost would be minimized. And we would just write that down. Our x value, the production where the average cost we minimize, would be those intersections of the average cost and the first derivative of the marginal cost, and that would be at x equals 201.24. Problem is we wouldn't write it like that. Items usually don't make 0.24 of items, so you would write it as when 201 items are purchased, the average cost is minimized per item. Okay, let's take a look at another idea. Anytime we're making things, manufacturers always want to maximize profit. And that makes sense to all of us, right? So a couple of things you got to think about, not just the average cost, but also the revenue. What price are you going to sell it? And you think about at what certain, and just in basic economics idea, when something gets too expensive, people won't buy it, but you want to make the most profit. So you want to first think about your total profit, and our profit, it has to do with the revenue and the cost. So if we think about our x is our items are sold, and our price, our P of x function would be the price per item. And that can fluctuate depending on demand, depending on time of year. The holidays, a lot of times the prices might go up, or they could go down based on stock items, how much is in everyone's stock. So just to simplify it a little bit, we're going to be looking at the revenue function. And the revenue would be the X, the number of items sold, times the price that we're selling the item. So our total profit of our function would be the revenue, how much money we're going to make, minus the cost. And this is just looking at an item. There's lots of costs, and so companies will look at different costs in general. But we're just looking in a basic idea. So the company has taken in everything we can think about. It has its revenue minus its cost to come up with a profit. So again, we have this maximize idea. They want to know when is the profit maximized. So anytime the profit is maximized is when the derivative would be to 0. Right? Anytime we have a max, we could have it when the derivative is 0. So to take the derivative of my total profit, we don't have to use a quotient rule or product rule here because we can use the sum rule. We're just going to have our derivative of our revenue minus the derivative of our cost. So our derivative of our profit is going to be equal to the derivative of our revenue function minus our marginal cost, our first derivative of our cost. And we're going to find that when it equals 0. So in this case, we're going to see that anytime we have it maximize, we're going to have our first derivative of our revenue equal our marginal cost. That's our ideal situation when we're going to make the most profit. We are also going to use our second derivative to prove it's a maximum. So just going back to our last couple classes, our second derivative would be the second derivative of our revenue minus the second derivative of our cost. And to show it for the maximum, we want the second derivative to be less than 0. Therefore, our second derivative of x minus our second derivative of our cost function, so our revenue second derivative minus our cost second derivative would have to be less than 0. Another way to think about it is just thinking about our revenue. Our second derivative of revenue must be less than our second derivative of our cost function at that x value. Okay, so if you need to pause the video to write that down, go ahead and or replay what I said. We're going to try an example here and hopefully put it all together. Okay, so here's our same example of the same cost function, but now we want to make sure we get our total profits. We have looked at the average cost, and now we want to look at our profits and our revenue. So this first part of our question, it gives us that same cost function and it gives us the demand function, our profit, our price per item. So they want us to find our revenue. So to find our revenue function, we're going to multiply our price times our x. Okay, so pretty simple algebra here. We're just going to multiply x by our p of x. Okay. So our revenue function is 36.5x minus our 0.008x squared. And so this is our revenue function that we're stating that. Now they want us to find our marginal revenue function. So that means they want us to find the first derivative. So I'm just going to take the derivative of this using the power rule, and we have 36.5 minus 0.016x. Okay, let's see what the next question is. They want, just what I had originally thought, they want to know what our maximum profits are. So we'll need to see when the first derivative, just going back to what our notes were from last, we want to maximize profit when our first derivative of our revenue function equals our marginal costs. So we know our first derivative of our revenue function, and we also know, because we've already did this part of this problem, and we want to know when they're going to be equal 0. We are going to use a calculator for this, but I want to go ahead and just do a little bit of algebra. I think it'll make using the calculator easier. So if I set my first derivative equal to my cost function derivative, marginal cost. So in my marginal cost we did last time, and that would be our 0.00 3 zeros there and 39x squared plus 0.004x plus 5. Now this one I'm going to approach a little differently than our last one. We could use the calculator and put this in as one function and this in as the other and do the intersection. But I just want to show you a different way. So what I'm going to do is bring all of our items over to one side and set this equal to 0. And then I am going to use our calculator again and look for the solution. So let's go ahead and first do that. So I'll subtract 36.5 and add 0.016x. So this side will be 0, and our quadratic function would be 0.00039x squared plus 0.02x minus 31.5. Okay, so let's put this quadratic function into the calculator and look for the solutions. So remember how we do that. We just plug in the equation into the y1, then we graph it. You might have to make your window bigger. I made mine the x value bigger when I couldn't see the full 0. So we can see that there would be another x-intercept over here, another solution, and remember another word for that is zeros. But we won't have to worry about our this solution because we won't produce, this is on the would be a negative x value, and we won't produce negative x items. So this is the only solution we have to worry about. And I'm going to use my calculator, the second trace, the Calc button, and go to a 0. And the way you have to find that, you go to the left side of the 0 on your function and then move your cursor then over to your right side and hit enter, and then it asks to guess and you go close to the spot, and we get for our solution would be 259.71. So our solution for this item would be when x is equal to 259.71. So we would say to produce 260 items, because you would round up from 259.71. So I want you to go ahead and try the proof on your own, and then I'll bring you back. Remember, the proof includes the two second derivatives. Okay, so you should have found your second derivative for the revenue was always going to be a negative, and our second derivative for the cost function at 260 would be a positive number. So you've proven that this max profit is 260 because our second derivative of 260 is less than our second derivative cost function.